Hi, I'm Deanne, and this is my friend Bob, who's currently a bit sick with what seems to be a cold. Colds are a common experience that people face every year, especially during the fall. Right now, we're only able to treat the symptoms of a cold with over-the-counter medicine, but there's no vaccine or any cure for the cold itself. However, our research just might be able to change that. The most common factor of a cold are these tiny agents called the rhinovirus, especially Rhinovirus-C. But besides the common cold, RVC can lead to further respiratory complications such as asthma. The key to tackling this virus lies in a protein called CDHR3, which can be found in human lungs. And previous research says that the more of this protein we have, the more likely it is for us to get infected by RVC. In fact, the virus usually binds to a specific site on CDHR3, which is how it enters our cells. Therefore, the overall objective of our study is to prevent the attachment of rhinovirus-C to the binding sites of CDHR3, thus repressing the viral infection in our bodies as well. To accomplish this goal, the first objective is to improve CDHR3 solubility, which allows us to better observe the protein's behavior. In order to do so, we're introducing a mutation in the gene that codes for CDHR3's exterior. First, a method vital to this experiment is called site-directed mutagenesis, which allows us to change one point of the protein's DNA sequence. When we have a soluble protein, then we use gel electrophoresis to ensure that the protein structure has not been compromised. Once the mutation is confirmed to be present in our protein, we want to amplify the new sequence in order to better observe its functions. Lastly, as a final checking point, we need to run the DNA sequence through a software program. As you can see, the original top DNA sequence and the new bottom sequence has one different letter, proving our mutation is indeed present in our gene. After a more soluble yet structurally similar CDHR3 protein is attained, then we hope to develop antibodies against CDHR3, which will target the protein in our airways and block RVC from attaching to and infecting us. These potential findings will guide our mission to develop a vaccine that prevents RVC complications in human cells and thus ultimately let us lead healthier lives. I gotta go give Bob some medicine now, but thanks for listening.